Yes, all right. I think it's working. So, good evening or morning or good night, everyone. Um, Let me open my camera real quick. Yeah. So, I am Ayşe Suslu, co-lead of the GDG on Campus Maltepe. On behalf of our organizing team, I would like to welcome you all to the Build with AI Kickoff workshop. Well, today we are bringing together students and communities from different countries, which includes Turkey, Spain, United States, Malta, and Azerbaijan. This collaboration is one of the most important parts of this hackathon. The goal of this program is to build solutions that address real-world problems. Well, for that reason, every project should be connected to at least one United Nations Sustainable Development Goal. There are two main requirements for this hackathon. First, your project must clearly align with the SDG. Secondly, you're expected to deliver a working MVP deployed on Google Cloud with a public URL. Projects that remain only as ideas or hackathons will not be evaluated, sadly. We also encourage you to form hybrid teams with participants from different countries. This will be especially important for the Global Collaboration Excellence Award. We know that May is an exam period for many students. Well, because of that, only this kickoff workshop is kind of mandatory. After today, the remaining process will continue asynchronously, and teams will be able to work at their own pace. Now, to guide us through the technical part of today's workshop, I would like to hand over to Mr. Abdel, Google Senior Developer Advocate. So, Mr. Abdel, the stage is yours.
Thank you so much. Hello, everyone. All right, so I don't really have a lot of time to actually, but normally the way we would do this is we would give people access to Go Cloud, and we will give them access to material so they can learn how to build agents themselves, and we can go through it together, and then we can guide you and help you and unblock you and what's up. But I don't have time to do that because it needs time. So here's what we're gonna do. I'm going to build together with you an agent live. We're gonna go from the basics of how agents work. We're going to be using ADK, Agent Development Kit, which is Google Cloud framework for building agents. It's completely open source, and it doesn't have to be Google Cloud. It can use actually any models anywhere, right? And so we're going to build something basic, and then we're going to look at the UN sustainability goals, and we try to modify the agent to fix one of those sustainability goals, right? We'll see how far we get in this setup. But the goal here is to at least start somewhere, and then we will build on top of that as we go. And so with that, what I'm going to actually do is I'm going to take an existing agent that does something and try to modify it rather than taking like an agent that will be like rather than building something from scratch. So let me just give me 1 second. I'm just trying to figure out which one do we actually want to use. Let's use this one. All right, this sounds like a good agent to start with. Okay, cool. So I'm gonna share my screen. 1 second here. And what you're seeing, what you should be seeing right now is Visual Studio Code, hopefully. It's coming. Oh, I cannot share my screen. Why?
Do I have to enable something in order?
No,
Oh,
no.
I think, yeah.
Okay, cool.
It's working now.
Do you see my screen, right?
Yes.
Okay, good. Okay, I can see it also. That's good. Okay, so what is an agent? That would be very good, a good starting point, right? There's actually a diagram that I want to show you, which explains very basically what agents are, and it's a super basic explanation. Let me I think that this visualization here would be a good starting point. Let's say this one here. No. Give me 1 second. Oh yeah, okay, here is a good starting point. Let's just use this one here. If I move my screen, no, not there, there. Ah, okay. And I'm gonna actually, let's do the following. I'm going to go ahead and share my entire window. There we go. We share this. So agents are kind of very basic really in their functioning. What agents are, they are just autonomous applications. So think about it this way. When you get to build an application yourself, you get to actually define what that application does. You define what we call the logic of the application. So you say, okay, my application has these functionalities. It can implement these things. And then you have to write the code or maybe use an AI to generate the code. But you have to, at least as a developer, you have to tell the tool or the AI that you're using what is the logic you want the agent to the application to implement. Agents are essentially an application that in its core has access to a large language model. And then it can use that model to make autonomous decisions about the next steps. So what you see here is on the left side is your agent. That's the application you're going to be building. In this particular case, we're going to be using ADK, Agent Development Kit. And the user interacts with the agent. So the user talks to the agent. Then the agent will use a model, which is what you see on the top right corner, the red box. So that's a large language model. And that model is the brain of the agent. That's what tells the agent how to behave. And then an agent can, and I insist on the term can, it's not mandatory, but it can have access to what we call tools. And so tools are functions that you define as a developer, and then you give those tools to the agent. You tell the agent, hey, this is a tool that you have access to, or you can use. And what the agent will do is that it will talk to the model, say, okay, the user said this, the user asked me to do this, and then the model will take the user prompts, so the inputs, and then it will take the knowledge of how the tools are, and then tell the agent how to behave. So that's the agentic workflow, that we call it. That's essentially what makes agents autonomous, in the sense that what the agent does is vastly defined by what the model does, right? Now, this is one of the things to keep in mind about agents, is that they cannot be completely autonomous, because agents are only limited to the tools they have access to. They cannot invent new tools. They cannot create new tools, right? So if you want to give an agent a capability that it doesn't have, you have to implement that as a tool. And I'm gonna show you an example here. So let's just start with something, right? Agent Development Kit, ADK, is available in multiple programming languages. It's available, I think, in Python, Java, TypeScript, and Go. I'm going to use Python because that's a programming language I like. And for Python, if you have never used Python before, any programming language, doesn't matter where it is, which one it is, has a package manager. So that's the piece of code, or a CLI usually, that allows you to install dependencies. So Python has pip, PIP, usually. That's what usually people use. But I like to use something called UV. And UV is much faster. It's written in Rust, and it's super fast dependency management for Python. So I'm going to create a folder. Let's call it UN agents. UN agents. Just move it to the right folder. And then I'm going to go inside that folder. And then I'm going to initialize a UV project. So it's UV init. That basically tells UV this particular folder has dependency done through UV. So I'm going to try to go inside that folder to show you how it looks like for now. There we go. Open. So this should load my projects. Okay, good. And what you can see here is I have few files. The main file is this thing called pyproject.toml. This is essentially defining my UV projects. And the most important part here is this, dependencies. So now this is where I should start adding any dependency I have. So for example, in my particular case, I need to use Google ADK, and Google ADK is a Python dependency. I can type it here. My preferred way of doing it is just to use UV itself, the command line, to manage the dependencies. So UV add Google ADK. So this will actually download the dependency, install it, and then add it in my dependency file. So just to be very clear, I'm supposed to pin a version. So I'm gonna do the right thing. And I'm gonna, it's not a good recommendation, by the way, to leave your dependency pinned to the latest, because if I don't specify a very specific version here, whichever, here we go. Okay, UV fixed it for me, good. So it says basically install Google ADK in a version which is superior to 132.0. I'm just gonna actually say I want exactly 132.0. If you don't mention it, each time you build the project, it will just pull the latest version, which is not a good recommendation. Good. So now that I have my my ADK or my Google Agent Development Kit dependency installed, I can basically use it. And if you are using UV, whenever you need to run something, you need to execute UV run and then everything after UV run. So I'm just gonna do ADK, which is the command line for Agent Development Kit, and then I'm gonna call it create. And let's do something basic. Let's just say weather agents. I'm gonna build something basic, and then I'll extend it to something more complex. So yeah, good. So I'm gonna do this. So what this will do, it will create a weather agents folder for me in this root folder, and then inside that I will start defining the code of my agents, right? So I'm gonna wait for it to actually finish. So give it a second. By the way, this is not a presentation in the sense of like I'm not doing a talk. So if you have any questions, just feel free to throw them in the chat. I'll be answering questions as we progress. So this will initialize my first agent called, it has to be underscore. There we go. This should work now. Yeah. So now I will get a bunch of questions that I need to answer. So as I said earlier, any agent needs access to a model, right? Because this is Google ADK, it's by default designed to work with our models, so Gemini. But you can also run like Gemma locally on your laptop and connect it to Gemma or to any local model, or connect it to Anthropic, OpenAI, Claude, whatever you want, right? So just because it's simple for me, I'm just going to choose Gemini. You could, of course, choose two, and then later it will prompt you to say which model you want to configure. Then I'm going to use Vertex AI. I'm going to not go to the details. Just this is an implementation detail. This is my project. And I'm going to use Europe West 1 because I live in Europe. It's easier for me to use Europe. So all these answers that I answered, they're all available inside my weather agent file .env file. These are just environment variables, right? I can edit them if I want later, right? Now, I didn't do much. I just created a folder called weather agents, initialized an agent inside, answered a bunch of questions. But believe it or not, I already have an agent. It's not a very useful one. It's actually very useless. But let's see how it looks like. So ADK, Agent Development Kit, comes with a web interface, which is meant to be used by developers. So it's a debugging interface. So if I do UV run ADK web, and I load this localhost 8000, so that will load my ADK web interface, which I will load here so you can see it. There we go. So what you are seeing actually here is you are seeing the Agent Development Kit web interface. And it comes with multiple things. I can actually change the theme to clear. No, let's leave it on dark. It's easier. So here I can already start interacting with the agent. I told you earlier that an agent has, like, the interface to talk to an agent is a prompt. So you are expecting the user to talk to the agent. So I can say, hi, how are you? And this is basically going to send a request to Gemini and then return a response. But because my agent is super simple, I can, for example, ask it, let's start a new session. How do you start a new session? They changed the interface recently, and now I don't know how to do that. No, that's not what I want. New chat. What is new chat? New session. There you go. Okay, sorry. Let's say, hi. What is the weather today in Istanbul. Yeah, Istanbul. Let's do that. So let's see. It's going to tell me that it cannot. I cannot provide real-time weather information. My capabilities does not include accessing live data such as weather, blah blah blah. So it's basically a pretty useless agent. It cannot do much, right? It's just like whatever question I ask it, it's not going to be able to answer me. But that's because I didn't really do much yet. I didn't implement anything. So now if I want to make this agent useful, I can go inside this agent.py file. By the way, any agent, this is the root of the agent itself. So the agent.py file is like the core of the agent. So you will see that there is an import, and this is how we start the agent. We create what we call a root agent, which is the basic one. And agents actually can have multiple sub-agents. So they have a root agent, which is the orchestrator. So that's the one that receives all the requests from the users and the response. And then it can have multiple sub-agents to which it can delegate tasks. So I'm going to change its description. You are a helpful weather agent that answers the questions of the user about weather, right? And then I will give it an instructions. So the description tells the agent what it's supposed to be doing. And this is very crucial when you're building agents, that you have a good description, because that basically tells the agent what it's supposed to be doing, right? And then answer user questions about weather by taking the city as an input and using the provided tools to get weather information. So this is the description. And now to make this agent a little bit useful, sorry, I'm going to define a function called getWeather, which has one input. So let me, I'm going to go ahead and copy that. I don't want to spend time doing it. Just give me 1 second. Yeah, so let's say I'm going to do city as a string, and then I will return, no, not there, a string. And then here I'm gonna, so because normally this is the function where I will make a call to an API that returns the weather information and then return that to the user. I don't want to spend time doing that because I don't have time. So I'm just gonna do a very simple return. I'm just gonna do weather in the city is 21, let's say 25 degrees. Again, this is a pretty useless implementation, but just to give you an idea. So now I defined a function. This function is called getWeather. And normally, actually, when you are defining tools for agents, you're supposed to also provide a description. So getWeather returns the current weather data from the remote API. It sends the city as an input to the API and returns the numerical value. So numerical value. All right. So I defined a function called getWeather, and I have to give it a description. And normally, actually, if you're building something useful, you will also define like inputs, city, outputs. So this is important because all of this will be read by the current weather in C. All right. So this actually will be read by the model to know exactly what this tool does. Now, what you can see is I just defined like a simple tool function. But what actually makes this a tool is the fact that we just go here and then we say tools, and then we give it as an array. So we pass the tool as a list. So now what we did is we defined an agent called getWeather. We defined a function called getWeather. We give it some description. What the function does is not very important. And then we did that as a tool. We passed that as a tool to the agent. So we told the agent you have access to this get weather. And so now I'm going to go ahead and stop this. Actually, if I want to avoid stopping it, I can just do -- reload agents. If you do -- reload agents, it will reload the agent each time you change the code. And so now I will go and refresh my agent page and say the same question. What's the weather in Istanbul? And hopefully, if everything works well, I should get a number. Oh, there we go. It's working. So it's 25 degrees, but that's because I hard-coded the value, right? It's, as I said, it's not, yeah. But you notice here, for example, I said, what's the weather? This actually is a tool call. So this tells me that my agent, because I prompted it, what's the weather in Istanbul, and based on the description I give the agent and the description I gave the tool, it have decided to call this function. And I can even actually see here the request that was made. So if I click here, I should see that the request was, this was the request, answer, blah, blah, blah. And then the response was somewhere. I should be able to see that I have the agent call. Here we go. So if I click on this, it tells me that the agents have actually called the function. You see function response. It called the function called get weather, and then it returned some data from that get weather. So this is very basic, right? And this is actually basically what an agent is. This is like 101 how to build an agent. Like we've done it together. We have built an agent. It's very simple, right? Very basic. Now let's do something more useful, right? And so in order for me to do something more useful, I am going to actually go ahead and let's see, which one do we really want to do? Yeah, let's do this one. What does this agent? I'm trying to find something that will be useful for all of us. Enable APIs. No, I don't want to do that. This requires too much work. Prepare the development environment, blah, 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 blah. Okay, what does this thing do? Scaling. Okay, preparing the application. Okay, so we have this agent called Zoo Guide. Let's just try to use this. Let's see how easy. Pip install, blah, blah, blah. Okay, good. Create an agent workflow. Okay, here we go. So, good. So what does this thing do? Add prompt to states. And chain two. Yeah, okay. Let's do that. So I'm going to build another agent. So I'm going to stop my EDK now. And I'm going to go ahead and initiate new agents. Which I'm going to call, I'm going to call it Zoo Agent. Let's call it Zoo Agents. Zoo Guide Agents. Okay. Again, remember, UV EDK creates, and I'm going to call this UV run EDK creates Zoo Guide Agents. All right. So this agent is very basic. I don't know what it does, but we'll figure it out together. Again, same thing, answering a couple of questions. I'm going to use Gemini, Vertex AI, this project, Europe West 1. And then good. Okay, so now I have another folder called Zoo Agents. And so inside that, I'm going to define an agent that does something. And I'm just copying from an existing thing. So I don't really know much what's going on, but let's do this. So, okay. So I'm going to copy all of this code here. And then we're going to go through it together. We're going to define a tool. Good. And then we're going to define my agents. Good. Okay. And formatter agent, now I need to define another agent here. And then I'm defining the root agents. Okay, good. Okay. This is the full agent code. Okay, good. So I'm going to define all of this in one go. Okay, good. And then I will go ahead and install the dependencies. Just give me a second. Okay, so this agent needs a couple of dependencies. So this particular agent has a couple of dependencies like these. So it has Google ADK, of course. It uses another library called LangChain Community. So LangChain is an open source library for calling large language models. It's not very important. And then I have a dependency called Wikipedia. So what this agent does is that it can actually call the Wikipedia API via library, right? And so if I look at my agent code, what I have here is it's a little bit more complex than the one I built. But so let's say I start with a tool called Wikipedia tool. And so this tool is a LangChain tool, which basically allows me to access Wikipedia through an API, right? Then I have an agent called Comprehensive Research Agent. And what this agent does, it can access both the internal zoo data and external knowledge from Wikipedia. So we give it a bunch of instructions. You are a helpful assistant. You have access to two tools, a tool that gives you access to some data about our zoo. So we're building a zoo knowledge database or a zoo knowledge agent. So imagine, for example, you are building an agent for a zoo where the user can, visitors can go to the zoo and then ask questions about a specific animal. And then it gets information from the internal database about like that particular animal, where did we bring it from, what's its story, how old it is, etc. And then it uses Wikipedia to get like general knowledge information about lifespan, facts about that animal, where it grows, where it usually lives, etc., etc. And then we give it some more instruction. We say, first of all, you have to if you can answer the question of the user using one tool, use that. If not, you can use both the database and Wikipedia. And then you have to sanitize the results and return them. So this is just one tool, right? Then we have a response formatter agents. So this is where it gets interesting. This is where we start building what we call multi-agent system, where we have one agent that does research and another agent that does formatting. So what this agent does is that it will take the information from the research agent and then formats that output in a specific format, right? And then we have a tour guide agent, which can, so this tour guide agent is the main agent that we call, and then it has two sub-agents, the researcher and the formatter. And we call it a sequential agent. But what does it mean sequential? It means basically it will run the sub-agents in order. It will run this first agent first, the researcher agent, and then it will run the formatter agent after that. ADK, Agent Development Kit, has multiple types of agents. Sequential is one of them. But you also have ADK sequential agents. You also have what we call parallel agents. So you have sequential agents, which can run agents in an order. You have what we call loop agents, which runs agents in loop. So this is actually pretty useful. Let's say, for example, you are doing a summarization. So you can run an agent, give it a text as an input, and then tell it you do one pass, and then you sanitize the information, and then you do a second pass to sanitize more, and then you do a third pass. The important thing with loop agents is that you have to tell them how many times you want them to run. Otherwise, it will run forever. So you have to give it like a certain number of executions. And then you have what we call parallel agents. So that will basically run agents in parallel, right? Very simple. Then we have our root agent, which basically does the thing that the root agent does. I have a model name here. Yeah, okay, all good. Great. All right, so let's do something. Let's execute this and then see it working. UV run ADK web -- reload agents. Let's see if, oh, okay, interesting. Hold on. I have some, no, it's good. I know why. I was missing the quotes. There we go, okay. So I don't think I will, actually, I have to do UV sync because I added new dependencies now. All right, so that will sync my project, so to install new dependencies, and then I will execute it. And I'm not seeing any questions. I don't know if you don't have any questions because everything is clear, or Yeah, you can. You can add a stop condition to loop agents, such as if the summary text is under 200 characters or something, or does it have to be a number that has to be specific? That's a very good question. Let's see. Max it. Okay. Yes. So termination check. You can have a max iteration, which is you set number of iterations, or you have an escalation from a sub agent. So you can actually design an agent to evaluate a specific condition. For example, is the document quality good enough? That would be the example that is this text less than 200? And then that will basically raise a condition to say, okay, we can stop the loop. So the answer to your question, Serkan, is yes. Good, somebody is following at least. All right, so let's do UV run ADK web. I think there was a question about the YouTube video. I think it will be shared. I believe you guys will share it. All right. Now, okay, great, cool. So now let's go and see how this agent looks like, right? You remember earlier I was working out of the same folder because I have multiple sub-agents. I ran the web version of the ADK from the subfolder, and then now I can select which agent I want. So now I have a new agent called Zoo. And let's see what would be a good prompt to type to this agent. Okay. This is a very basic one. Hey, I am at the zoo. I am your zoo. No, okay, no, that's not that's prompts. Yeah, let's take this one. Where can I find the polar bears in the zoo and what is their diets? So let's see if we can. Okay, it's broken. Why? I have something broken. Internal server error. Oh, what's missing? What's going on? Oh, it's not. It cannot call the model. Interesting. Okay, let me check why. Okay. Yeah. Okay. I see why. Right. I think it's. I think that this is this. Yeah. Okay. So if I go inside .env, I can. No. Okay. I can actually go inside .env and just add model equal, and then I will add my model ID, which is Gemini 2.0, 2.5 Flash. Okay. And then, all right, let's try again. This should load my agents. I'll do a new session. Sorry. Up. Hopefully this just works with no errors. Yeah, okay, cool. It sounds like it's working. All right, cool. You can see already that my agent is doing something. And I'm going to reduce this. I'll come back to it in a moment. So I asked a question. And so there was this function called add prompt to state. I'm not going to explain what states are, but basically what you can do is agents have something called states, and state is in memory. So what you could do is you could, to keep the prompts so you don't lose the history, you can just like append the states to the memory. So that's why we have this function called add prompt to state. And what it does is that it saves the user prompt into the state, essentially. And actually in ADK Web, you can see it here. You can see how many prompts I have. So that will basically save all the prompts and all the answers, right? Then I have, so that's good. Then I'm doing a transfer. So this is essentially transferring from one agent to another. So here, I'm transferring from the root agent to the tour guide workflow. You remember in my code, that's essentially the root agents is this one, which calls the tour guide workflow, and it has a tool. So it will call the tool to append the states, and then to append the prompt to the state, and then it will call the tour guide workflow. And the tour guide workflow is the sequential agent, which has the two sub-agents, right? Then that will transfer to a different agent, which is the Wikipedia one, right? And it got me an answer. So And then once it got answer from the Wikipedia, it actually did sanitize it. So yeah, so I can tell you the blah 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 are mostly carnivore blah. So this is coming from Wikipedia. This information here is coming from Wikipedia. In my particular case, I basically built an agent to access some internal database, but I didn't really give it the data. So I'm gonna just ignore that for now. But basically, if you want your agent to access some internal data, this would be the opportunity for you to give it access to that particular information, right? So here, basically that's it. So this question: at what point do we consider using MCP? That is a very good question. MCP would be useful if you're trying to use the agent to access an external endpoint, right? So in this particular case, we're actually using Wikipedia via an API. But if the API you're trying to access has an MCP server, you will just use the MCP server to access it. So MCP is just like a way to access APIs, right? The key difference here would be if there was an MCP server I want to access, I will just I don't have to write a function to do that. I will just tell my agent, hey, there is an MCP server that you can use to access my data. So this is actually a very good question. So if this particular case, I had a database with all the animals in the zoo, I would expose those animals in the zoo behind an MCP server and use that to access the database. That would be one example, right? Will we share the code file? No, but I will share some. I will share actually the steps I follow to build this agent, so you can build it yourself. It calls another agent, though not a basic function. It might be a bit wasteful regarding resources, right? No, not really. No. I mean, the whole point of doing multi-agent system is to actually, one of the best practices for building agents is that you have to make sure that the agent can do only one specific thing. Agent transfer doesn't cost you anything. And actually, it's a best practice also if you're doing multi-agent systems, because what you could do is you could deploy them separately from each other and use A2A to talk to each other so that you can scale them differently. So if you're doing a production system, you might want some agents to scale separately from other agents. What I'm showing here is a very basic example, but for production systems, you might want to actually deploy the agents separately from each other, just to make sure that scalability doesn't become a problem as you grow your application. So yeah, so this basically shows how we can build the basic agent. So now, actually, what we could do together is, if you want, we could try to look into this sustainability goals and maybe work on one of them for the rest of the time. I'm not sure we have time to do it, but let's see. UN sustainability goals. So let's pick one and then try to implement something just for the fun, because why not, right? So we have, let's do the clean water one, right? Actually, this would be fairly easy to do. What I could do is I could modify these agents. And so I already have a Wikipedia agent. So I don't want to modify that. I will keep this add prompts to state, which will be useful. So I'm not going to touch it. I'm going to keep the comprehensive researcher, but I'm going to change its description. So I will tell it the primary researcher that can access boats, that can access information about where to find, let's say, for example, how to find water sources, or let's say how to filter water to make it drinkable. This would be pretty useful one. Answer the user prompt, tool for specific data. Actually, I'm going to remove this. I'm just going to keep that you have access to one tool. You have access to one tool, a tool for research in Wikipedia for general knowledge on filtering water to make it drinkable. I'm making a very simple agent here, right? blah, blah, blah. Finally, use the prompt. If the prompt can be answered using one tool, use that tool. If the prompt is complex and requires blah, blah, blah. Okay, so I'm going to remove this instruction here. Boom. And I'm going to use, okay, just leave it. Okay, use one tool to answer the question and then sanitize the results before you return it. It sounds good to me. Then I have the response formatter. I'm going to leave the response formatter there. Sanitize all information. You are for the water filtering guide. Your task, blah, blah. Okay. First, specific information about specific. Added the interesting. Okay, I'm just gonna remove all of this. I don't need it. Okay, good. Then here I have my. I'm gonna actually remove this and I'm gonna replace it with. Actually, I'm going to, because I only have one sub agent, so I don't have two, or do I have two? No, I have two. So I'm gonna actually leave them. Yeah, I'm just gonna rename my tool. I'm gonna call this water facts agents. I'm gonna call it water facts agents about water. I'm just doing something very basic here. This is not scripted. I didn't really prepare enough of this, right? Blah, blah, blah. Water facts agents about the all right. Okay, after that, to the water facts agent. Sorry, has to be called water facts agent like that. Okay, good. Blah, blah, blah. And then here I have my sub agents. Okay, let's see if I didn't break anything. I should have fixed everything. Yeah, I should be good to go. So I'm going to reload my section. I'm going to choose this agent. I should have renamed the name, but it doesn't matter. I found a lake with greenish water and I want to drink it. Can you, let's see if it works, right? Can you guide me for how to filter it out? There we go. Let's see. Hopefully I didn't break anything. Seems like I didn't. All right, let's see. MCPs are just predefined tool sets that are provided by the devs natively, right, for the ease of use. MCPs are just servers. Oh, no, I want you to help me. Okay. I have modified it. It should just work. Let me double check something real quick. Yeah, I know, it's all good. Okay, I'll actually reload the whole thing. Let's see if this works. Hi, what can you do? Let's start there. Actually, MCP is just like a proxy. Oh, okay, good. I found a lake with a greenish water. Is it safe to drink? Can I filter it? Let's see if this works. And then I will answer the question about MCP. Okay. All right. So it did the thing. And it returned an error. Okay, there is an error somewhere. Let's see where this error is. The error is in JSON decoder. Oh, okay. Let's try one more time, and if it doesn't work, I will stop here. But you like that. The whole point here is you'll get the idea about what I was trying to do. Yeah, okay. So it's broken somewhere. I'm not sure how we can fix it. Let's see. Can I actually fix it? That's line whatever, expected value, event generator, response received from the model. I'm not sure if this is actually an error in my code or is it an error in the sequential agents. Hold on. Is this an error somewhere here? I passed a water fact agent. Good. I have that. It's called this. It has these two agents, comprehensive response formatter and then comprehensive researcher. And it still fails. Okay. Well, I don't know what's going on, but okay. I'm not gonna spend time trying to fix it. I'll try to answer some of your questions. MCP are just predefined tool sets that are provided by the devs natively, right, for ease of use. Yes, basically, MCP servers are like, MCP is just a standard protocol for models to call remote endpoints. That's what MCP is. So if you're using MCP server, you really don't need to implement anything. The model itself knows how to call MCP. It will call MCP, get the data back, and then use the data. So you can either use an existing MCP server that somebody built, or you can build your own MCP servers. It's really up to you. How do you want to use it? And with that, I don't see any other questions. And we are almost at the top of the hour. So I will try to leave maybe few minutes, maybe up to half an hour. I'm here up to like the next half an hour. So if you have any questions, what are the API wrapper? Can you use external SOAP beside Gemini? No, so this is an API wrapper for Wikipedia. Gemini is not a source. Gemini is a model. Gemini is the model that the agent used to think, quotes unquote, to actually perform the agentic workflow. So you can use any model you want, of course, but the API wrapper I used here is just an API wrapper for Wikipedia. So I'm gonna send you the link to the agent I just built, the zoo one. This is it. And you can actually follow the instructions there if you want to build something similar. And since there was a couple of questions about MCP servers, let me, here we go. Let me do that. So yeah, here is an example. This actually code lab has access to, this particular code lab has uses an MCP server for BigQuery. So you have data stored in BigQuery and you can use an MCP server to call it. And actually we can take a look at it here. Give me 1 second. I don't want that. I want to share. Yeah, okay. So this particular case, we are using an MCP server. Let's see what it is. Yeah, so it uses this MCP server, which is the BigQuery one. And it defines maps MCP to, yeah, you have a function here called get BigQuery MCP toolset. It could also be this. It uses also an MCP server for Google Maps. And so here you just need to give it the API to be able to access that particular MCP server. And then you define that as what we call an MCP toolset. And then this function here is a tool to the agent itself. So if I go to create the agent here, I should see that, yeah, you can see here that one of these tools is passed as a tool to the agent. So the only thing we did here is we basically defined the logic for how to connect to that MCP server, including which API to use. We didn't have to implement the actual call for the MCP server for Maps or the MCP server for BigQuery. So that's essentially the key difference between using an MCP server and then building your own implementation for like an external API. For real-time industrial monitoring platforms using gRPC, data streams, and Vertex AI, what's the recommended Google Cloud architecture to minimize latency and cost? Oh, that's a very complex question. Real-time industrial monitoring using gRPC, data streaming, and Vertex AI. It's the recommended Google Cloud architecture. I mean, what do you mean by real-time industrial monitoring? Is it like an IoT kind of use case? The question is not super clear, so I don't understand your question. I know what the test streaming is. I know what Vertex AI is. I know what gRPC is, but I don't know what do you mean by real-time industry monitoring. So if you can clarify the question, I could probably answer your question. Oh, how would you manage API keys securely when deploying AI agents to Cloud Run? Very good question. Google Cloud Run has integration with something called Secret Manager. Let me show you, actually. I can show you right now. Actually, I will show you in my own other Cloud Console. Hold on a second. So I'm going to show you, not this, rather that. All right, cool. Up. And I'll show you that. It'll be very useful, actually. Boom. Okay, so if you go to Secret Manager, look for Secret Manager here. Secrets Manager is a secret store, right? So you could basically create secrets. You see I have a couple of databases. I have a GWT token. I have a Hugging Face. But you basically just do create secrets. You call it Gemini API key. Then you define like a function, a file or whatever. Let's say this, right? That's my secret. And then I just create it, right? So this is my secret. Now that I have my secrets, by the way, secrets can have multiple revisions. So actually, if you have a new API, you don't create new secret, you just create new version. And then you can promote that new version. So now if I create a new version, I will have version 2. Yeah, and then I can just do, I can view the value, right? Or what I could do is I could copy the resource name, right? Now, when I go to Cloud Run, Cloud Run, and I want to deploy something, I'm showing you from the interface, but it will be the same if you're deploying from the command line. So let's say deploy a container. And wait, there is actually, is there like, there is a, there's a container that can print its environment variables. Okay, maybe, okay, I'm gonna stop searching for things. It's fine. So let's say I want to deploy a container image, it doesn't matter. The point here is that somewhere in here, if you go to security, you see here there is variable and secrets, and then you can add reference secrets, and then you just define which secret you want to verify. So this is Gemini API secrets I created. I want to point to version 2, and I'm gonna call it Gemini _ API _ key. So doing this it will pull the secret from inside Gemini from inside Secret Manager. It will pull the value and it will make it available under this environment variable inside my container. So the container running in Cloud Run will have an environment variable called Gemini _ API _ key, and that will have the value of the secret. And then your app needs to just grab the environment from the environment variable. That's it. Oh, what is the simplest way to send real-time data to Vertex AI on Google Cloud, and what services handle the streaming parts? We don't really have an IoT service in Google Cloud, so you will have to either work with an MQTT provider to do that. That would be one option. The other option that you basically just stream them into the Vertex AI API directly. I believe the Vertex AI API streaming has actually a streaming API. It should have something. Actually, what would be easier is to send them to Dataflow. And then from there, you can just dump them into Vertex AI. So here is what you're looking for. Boom. So you create what we call a streaming pipeline in Dataflow. And Dataflow is our Apache Beam platform. So you write a platform in Apache Beam that receives all the data and then do all transformation and then dump it into Vertex AI. I haven't used AI agents before, but I'll be using it in this hackathon. If the agents conflict with each other and interfere with one another operations, how can we resolve the issue? Is that a common problem? No, if you orchestrate your agents properly, they shouldn't interfere with each other. So that's why you have these like sequential and parallel agents. and ADK will be in charge to do the agent transfer. So moving context from one agent to another, that's ADK. So they shouldn't actually interfere with each other. So if you define them as sequential or as parallel, ADK will orchestrate the agents for you. So it shouldn't be a problem. It's not something that happens ever, I guess. I would say ever. Yeah. All right. Do we have any other questions? Yeah, so PubSub Dataflow Vertex AI is the recommended pipeline for real-time inference. Well, for real-time ingestion, not inference. I wouldn't call that inference. Real-time ingestion, basically. Yeah, that would be the easiest way to do it. Yeah. And if you're if you are I mean, depending on how your data, how your sensors look like, if they're MQTT, then we have this reference architecture for how to implement an MQTT architecture on Google Cloud. And that uses actually brokers that run inside Google Cloud and then expose behind the load balancer. So you run the brokers inside Google Cloud, expose them behind the load balancer, the sensor sends data to the load balancers, they get into the broker, then from there into PubSub or like Dataflow, and then from Dataflow into Vertex AI. That's how we would implement it. All right. Do you have any other questions?
I don't think we have any other questions. So we would like to thank you again for taking your time and guiding us step by step. We're really, really thankful. Thank you so much.
Awesome. Thank you so much. Thanks for having me. I hope this was useful. And yeah, good luck for the hackathon, I guess.
Thanks.
All right.
Take
Have a good
care.
one. Bye-bye.
Goodbye.